What do you want?
I just need a TI launchpad.
Can't you see I'm busy here?
Don't be held hostage by the board order. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.
Hey everyone, welcome to the June episode of Make Live. My name is Tyler Weingartner, video producer here at Make Magazine, and I'm joined by...
I'm Hepspadia, Make Community Manager.
And of course, if you've been watching this for the past couple months that we've been doing these, Make Live is the live show where we build stuff live directly in front of you. We take your questions. We hopefully come up with answers if we have them. And we generally have a lot of fun and sometimes break hardware and sometimes make hardware. This is one of our Skillbuilder editions. So we're not actually going to be building a project today. What we're going to be doing instead is doing a big demonstration and experimentation with some of the concepts around the project that we'll be building in July. We're going to talk about that at the end of the episode. But in the meantime, we of course want to thank our friends at DigiKey. They make this show possible, and they're great partners to work with. If you're not familiar with who DigiKey is, you should be. They are a distributor of electronic components based here in the US, and they sell all of the projects or all of the components you need to build these projects and projects like them. They sell everything from individual LEDs all the way up to single board computers and microcontrollers like this Arduino Uno. They have everything, anything electronic they sell. They will sell it to you and they will ship it to you very quickly. They're great partners to work with. They make this series possible and we couldn't be more grateful to them. But anyways, let's get into what we're talking about today. And what we're talking about today is displays. And I'm kind of generalizing display as anything that you would use to get visual output out of your microcontroller or single board computer. And that's going to be everything from this guy here, this little LED, all the way up to well, one of these, which I don't have anything on here right now. I think if I power this on, no, it'll do a weird staticky display because I made it, programmed it to make static. But this is a like 3-inch TFT display, full color, full RGB color. It's also a touch screen too, so we can do little finger painty things on it. And basically, a lot of different kind of displays in between. And this is for a project that we needed a little screen for it to give you feedback on the state of the Raspberry Pi. So we're going to be showing off that display later. It's a little monochrome OLED display. But in the meantime, let's start getting into it. First one I'm going to show off is a simple LED. You might not think of that as much of a display. And of course, the first one we're going to do is the very basic sketch here. Get my tabletop camera out here. And of course, I mentioned that there would be an opportunity to ask questions as we go into any of these topics. Any question that comes to your mind related to this topic, go ahead and put those questions into the chat, and we will answer them, or at least do our best to answer them.
And you guys in the chat, I tried to fix my audio, so you let me know if it sounds better, and if not, we will boost the levels a bit.
Were you being a little too quiet?
I was being a little too quiet, which is unusual for me.
Just got to set this camera up a little bit. And now it's too bright, but that's okay. We have controls for that. Okay. All right, so this is the most simple setup we can go with here. This is an Arduino Uno, which if you have done any work or any experimentation with microcontrollers, you probably played around with this one a bit. And if you have done, you also recognize the sketch that I'm about to pull up.
Will you boost the levels on me a little?
Yeah. Let's see. You are on this one. How's that sound? How does that sound?
Hopefully the levels for me are a little better. We'll know in like 20 seconds, but you can let me know in the chat.
All right, back to us for a moment here, where I pull up the classic Blink sketch. And also, there's a robot behind us.
You can see this little guy back here, and his name is Unit. And if you would like to control him, you can go to letsrobot.tv and basically get an alternate view of this live stream.
Control will be sort of a misnomer. You won't be able to really. You're still too quiet?
Try clipping this out back in. All right.
Go ahead and,
Just a little bit more.
go ahead and say something.
Check, 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 check.
Yeah,
Oh
you
yeah,
were-
that's real low. Check, check, check. Try and move this closer. Check, 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 check. Check, 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 check. Hello. Check, check. Sorry guys, we're trying to get this audio situation sorted out.
Okay, that's me.
Check, check. Check, check.
That's better.
That's better. All right, now you'll probably have to let me know if I'm too loud.
Okay. Sorry about that. Okay.
But I was saying before, if you want to control our little robot friend, you can go to letsrobot.tv and look at the top for a unit, and you can see through his eyes.
Yeah. So what we have on the screen here, like I said, this is the classic blink sketch. And all this is going to do is just turn the LED on. We see here the meat of the code here, which is writes the LED pin to high, waits for 1 second, sets it low. So it's just going to blink the LED on and off. And going to be working with a few different boards on this one here. So we'll need to select our board. That one.
And if you aren't familiar with Arduino, but you are familiar with programming, this is essentially the hello world of hardware.
Yeah.
Everybody's first sketch. They said now your volume needs to go up a bit.
Oh no. I may have turned it down a little bit there. How do I sound? Do I sound good now?
Hopefully you sound, they said my volume was great, and I'll keep an eye on the chat for yours.
Okay. And now we just have a little LED blinking on and off. Okay, that may not be the most useful thing in the world in this example here. We can do all kinds of fun things like change the rate at which it blinks. So I'm going to change it down to 250 milliseconds or a quarter of a second, so it'll blink a little bit faster. Now, how is this useful as a display? Not terribly useful in this case. Really, you're just getting visual feedback on your code. But you can also use this sort of thing to, it's not the tightest fitting into the Arduino there. Although the Arduino Uno also has a little built-in LED. Get back onto the tabletop camera here. And focus. Yeah, you also see the little built-in LED there. I mean, you can get all sorts of interesting visual feedback. Say when your board enters into a particular state, like when a motor is active, you can have an LED light on or turn on, or when it's running through a routine. Like last year, we built the linear motion control slider. You can have it blinking when the program is actually active, because sometimes if you're doing a really long time lapse, you might not be able to tell when it's active. It's moving so slowly. Of course, on this board we have a couple of LEDs, the power on light, things like that. In fact, you and I were just at a hardware meetup a few weeks ago. What was the gentleman's name that was speaking there?
Joe Grand.
And his demonstration there was how you can use LEDs to get information out of hardware that maybe the designers didn't intend to. If it's something like a network router, they probably have that LED wired up so that it turns on when it's sending an on binary bit and turns off when it's in an off binary bit. And that's data. I mean, he had an example where he had a LED flash and you couldn't actually see it. It looked, it was strobing so quickly you couldn't see it with your own eye. But he developed another board that could read it and get serial data back out of that LED and basically transfer just through light data from one board to another. And that's cool. That's like just one of the many examples of the ways that even a simple LED can be a useful display. But let's move on from that because LEDs just by themselves, a little boring. What's better than a single LED? Well, how about a bunch of LEDs? This is a LED strip called a NeoPixel strip, and let's get it under the other camera here. Each one of these LEDs here is a RGB LED, and you control them. You can see, let me flip this over so you can read it the right way. Focus in a little bit closer. You've got 3 pins here. You have 5 volts in, digital in, and a ground pin. So you can control these with only 3 wires and address each pixel individually, set its color and its brightness, turn it off and on. Let's take a look at how we do that. We're going to move over here to this other board, which is currently out of focus. This is the Adafruit Metro Mini. We're going to be using this for a couple of different demonstrations here. I'm going to wire this. Make sure I'm getting this right. I think I'm getting this camera closer so I can wire this up as we're looking at it. While I'm doing this, do we have any questions from folks?
Yeah, feel free to pop your questions into the Facebook chat or the YouTube chat, depending on where you're watching us. Or even just commentary.
Or make the robot ask us.
Or you can talk through the robot behind us.
Use the camera to tell if I'm actually plugging this into the correct pin. I am. And let's kind of wrap this around the board here so we can illuminate our work area when we get this code running. Also, make sure we get the board back in the display or in the frame.
So the display next to the board is not actually a part of this board. That's for later.
Yep, we're going to be getting into that a little bit later
when we go into our more advanced display section. Hello, unit.
All right, now I got to back this back out of here so you can actually see the NeoPixels lighting up.
Somebody on the YouTube chat said they would love to have a robot claw arm in the next live stream to control. Well, you're going to want to tune in to later episodes of Make Live.
Because we're probably going to be doing something with
internet controllable robot stuff.
Yeah, with our friends at Let's Robot TV. Hopefully building one of these for this live stream. So you can see here the NeoPixel strip is just kind of crawling up and down and slowly changing colors as it goes. Let's take a look at the code that does this.
And do you want to tell them what pins you connected to on the Metro?
On the Metro, I mean, you can connect it to any pin here. I can even demonstrate that in a moment. Right now it's connected to pin 6, which is the, that was just based off of the pretty much anything you get when you download a set of libraries to help you do your programming for this stuff. You get a couple of examples. And the example in the Arduino library for NeoPixels from Adafruit just elects for pin 6, so I just opted to use that one. But anyhow, let's take a look at this code here. All right, so right now the way this code works is that it we have 3 different variables for red, green, and blue. And then we set a random number between 0 and 255 for each red, green, and blue value. What was that?
You could add the LED strip as a headband for the robot. Yes, we could do that.
We should do that.
Future builds.
And from there, we just have 2 loops here. We have one that goes from, or one loop that just counts up to 7. This is what makes the lights go up the strip. Then it calls a function that's just alter color, which we'll look at that in a moment. Then it waits a 1/10 of a second. And then a second loop that makes the, that turns the lights back off in the opposite order. And that function, all it does is you pass in each of the different color values for red, green, and blue. If the color is less than, or is greater than 255, it resets it to 0, and then otherwise just increments the color number value. Then it sends that back out to here, so you see it slowly changing colors. Take another look at the pixel strip here so you can see how it's doing that. And you see it gradually changes color as it crawls through it. Now, of course, again, this is more visually interesting than providing actual display. But if you imagine you had an array of these things, you know, you wanted for different states of the board, you can have red lights, green lights, or any color you want to indicate, you know, whatever function it is. And because you have multiple ones, you can address them individually. You can get a ton of different data out of your board, depending on, well, as long as the data you need to get out of it isn't more communicative than just colors and lights. But depending on how you set up your user experience, you can get a lot of information out that way. Of course, let's take a look at the, you know, each one of these comes with an example here, and the Adafruit NeoPixel example is quite good. So let's take a quick look at that before we move on. NeoPixel strand test. And of course, with this, we need. Oh, that's right. I was going to show off that you don't need, or you can set it to any pin that you like. So I'm going to move this to pin 4. Pin 4. You can see that here. So this white wire right here, that's the wire that's the data pin. Of course, we have 5 volts and ground for the rest of it. Let's get back into the code. So we need to change this from 6 to 4. The other thing we need to do is this is set up for a 60 LED strip. Ours only has 7. And the other important thing to know about NeoPixels is that they're pretty volatile in the sense that you really don't want to be plugging them in while your board is powered. You can do harm to your board that way. You can do harm to your NeoPixels, and that would be bad. So let's go ahead and send this over to. I need to, because I unplugged it, I need to tell it what port the board is on again. So otherwise it will say, I can't upload this.
I don't know where to talk at.
And here's the basic Adafruit NeoPixel demo. Many pretty lights. Although I should mention one of my favorite examples of using NeoPixels as a display was a project that I got to see at a indie game convention here in San Francisco called Day of the Devs. And that's a project from a guy who normally showcases his stuff at GDC called Robin Baumgarten. I'm trying to remember. I hope I got his name right. And the game is called Line Wobbler. And it is a it's a one-dimensional roguelike game played on a very dense NeoPixel strip. I think the strip is like 10 feet long or something like that. And your character is a little yellow dot that you try and advance up the strip to the end of it. There's monsters that attack you. They're red. And you have a little joystick that you pivot up to make your character move. And then when you stop, you have a shield, so the monsters can't hurt you. And then you also can waggle the joystick back and forth, and that does sort of an attack that attacks your enemies. And that is a full video game, and a pretty dang fun one, based on just a NeoPixel strip. So pretty compelling thing you can do with this stuff. Of course, there's also a open source version of that same game. Robin never actually shared his code for that, but the open source version is called Twang, Twang, and it's called that because the control for the game is not a traditional joystick, but it's one of the spring-loaded door stopper things. And anytime you can use more of those in user interfaces, I approve of that. But that's a really fun game and a really cool example of something you can do with NeoPixels. But we must move on because we have more displays to talk about. The next one I want to talk about is well, something that should look familiar to just about everybody here, and this is these are called 7-segment displays. And if you ever grew up around the area of digital clocks, you no doubt, well, even if you've used a microwave, you've definitely seen these sort of things before.
Now, Ignore My Chan wanted you to repeat the part about the power and the NeoPixel strips plugging into the Arduino.
Basically, when you want to change any wiring on your NeoPixel, just make sure your board is unplugged or powered off. That's the gist of it. Yeah, because it can be harmful to both your board and to your NeoPixels if you just unplug them without properly powering them off first. And I believe for this next demo, I may need to, well, either need to solder something up really quick or go get something from my desk. I think I'll do the latter of those. So I will be right back. Sorry if there's any nasty headphone noises here. I will be right back.
Put it on the NeoPixel strip before you go so they can see the cool animation.
Cool animations.
I'll kind of block the overhead light here. And you can see it's just running the standard test animation, which is actually pretty cool. And if you just wanted to add like a cool NeoPixel-y effect to something, this is more than enough cool little color phases and patterns. I'm really into the sparkly one, where it's white randomly shifting around. Thank you, Unit, for looking out for us by telling us that there's a flashing light warning.
Okay, I am back. Oh, and while we're getting into the code here, oh, this is the that's the example code. But I also want to talk a little bit about how you set the color, or basically how you display on these, and not just mangle my code here. But really, and this is just one of the functions you can use to set the color of individual pixels, and that's this. Well, strip is the name of the NeoPixel object in my code here. Then we have set pixel color. This just lets you set the color of an individual LED in the NeoPixel strip. The first, and you pass it a couple of different values here. This one is the number of the pixel that you want it to change the values of. In this case, this is part of a loop where I is just iterating up and down. So it starts at 0 and goes up to 6, and that indicates which LED is lit up. and then you give it two RGB or three RGB values, and these are different values of red, green, and blue, and that's how we set the individual colors of them. And if you set them all to 0, as I'm doing down here, that will turn the NeoPixel off. You don't get the brightness of them drops off pretty quickly. I think once you get below like 40. In fact, let's test with that. It might not be visible at all. Of course, we plug this into pin 4, so we need to change that. We should keep this moving, because we have a lot more to. So even that is actually still pretty visible.
Maybe 10?
Yeah, let's try 10. Yeah, because right now they're just fading back to like a dim white. Let's see what 10 does.
Oh,
Even
yeah.
dimmer white.
Very dim white.
But still, you know, for
NeoPixels are pretty bright.
let's see what 1 looks like.
And the chat wanted to know if we have a rundown of the types of displays we're going to discuss.
Let's robot off TV.
That's not one of the displays. Okay, so even 1, you see there's a little bit of light there, but yeah.
Tiny dim star.
Not super bright. The question about the types of displays. So the other types of displays we're going to be talking about, I should come back to me here, or come back to us, so obviously we've already talked about 2 different types of LED displays. Next we're going to briefly go into a demonstration of 7-segment displays. We're going to spend a little bit of time, mostly because I didn't get a chance to experiment with them a ton, so we're just going to look at the example code of these LED matrices. Again, you're not going to get a whole lot of fidelity out of these displays, but you could probably get something cool. At least make a smiley face. Next, after that, we're going to be talking about, you probably can't see this very well, but this is a, I should just move this over to the detailed camera here.
Should probably swap though.
Yes. Oh, wrong one. So this is a 128 pixel by 64 pixel OLED display. We have 2 different ones we're going to show off here. This one is a fairly cheap one. It has color in an interesting fashion where you'll see at the top is yellow and the bottom 3/4 is blue. And this one particularly talks over 2 different, well, this one only talks over the I2C protocol, which is one of the serial protocols you can use to communicate with it. We're also going to be looking at this one here, which is the same resolution of display. This one's a little bit nicer. It comes from Adafruit. And it will speak over 2 different protocols. It will speak over I2C and SPI. Right now we have it wired up to work over SPI. We're going to program it both to work with an Arduino and a Raspberry Pi. So we're going to spend a little bit of time with this. And then finally, we're going to take a look at,
This one?
where did it go? This guy right here, which is a full color RGB color TFT display. I'll focus it down here so you can see the whole thing. Particularly, this is the TFT Featherwing. And it's called that because this has one of the Adafruit Feather boards right there on the back. It has a micro SD card so that you can load up bitmap files on it for it to display. And yeah, you can do all kinds of cool stuff with this, including, as I mentioned earlier, this is a touch screen. So we might even load up a little finger painting program. So that's what we're going to be talking about today. And the next one is the 7-segment displays,
Yes.
which I need to do a little bit of wiring here to wire it up. Let's take my own good advice and unplug the board before unplugging and unplugging stuff in. And I mentioned I²C. That is also the protocol used by this 7-segment display. And I'm also going to use, we're going to use this so it's basically a counter for this little push button switch here. Take a look at it down here. So it's just one of these little clicky switches here. And every time we do that, it's going to count up. But first, we need to...
You come to dinner with me every night, Unit.
That's more where I want it to be. I don't know if I'm going to be able to see that well enough to wire it from here, but let's find out. So for I²C, you only need 4 pins to power it, or to connect it. You need power and ground, and you need 2 additional ones for the data. One for the clock, and the last one for the actual data here. Of course, first we'll connect power, and I'm just using these short bits of wire as jumpers.
Ninja Master asked what kind of switch we were using.
I don't know exactly what kind of switch those are called. I call them end-stop switches because they're the sort that get used a lot on 3D printers and other CNC machines as end stops. And let's see. Now I'm going to remember, hopefully, I believe analog 5 is for the clock. If you can see that there, that's designated on the board here as this C. And analog 4 is our data pin.
Are you guys trying to make a bomb?
Kind of looks like it, doesn't it?
We're making a very complicated clock.
Well, this would be a bomb with no explosives. A very boring bomb. And that should work. There's a question about the switch here. Let me focus in on it. Yeah, when you depress this switch here, yeah, it's got a little clickiness to it. And then it puts continuity between these 2 pins that you see wired up. I believe this is a double pole, so that when it's open, there's continuity between these pins.
Ninja Master and Stuff with Kirby say it's a micro switch.
Micro switch. Aren't they all micro switches, though? I mean, if we had one of those little tactile push buttons, I need to look at my code to remember how I had this wired up. So let's look at that. This is one of my recent ones.
The old clicky joystick type.
Yes. Well, I wouldn't say that the tactile switches are really that old. It says here my button is on pin 8.
And Aaron Ward on Facebook says it's a momentary switch with a common normally open and normally closed contact, not a double pole.
Would that then make this a double throw switch? I never learned all these terms. That's the trouble with when you learn stuff like this on your own instead of like going to electronics engineering classes. You never know what anything's called. All right. So of course we don't have our code set up to the board yet. We'll send that over right now. Not that we need to change anything in the IDE. We'll find out. It'll give us entertaining errors if we get it wrong. Okay, and it's probably hard to dim this down so it's easier to see. You see that that 0 is lit up brightly. And then when we close this switch, you can see it counting up.
Yay, we made a counter.
So that's just one thing you can do with it. There's as with everything in any of these, you got a good number of examples here. Who likes numbers? And particularly, this is the LED backpack display, and that's there's a 7-segment demonstrator here. Full screen that. And this just goes through a bunch of different displays. We'll upload it and take a look at the code in a moment. Of course, it's not going to pay any attention to our push button switch.
When you get me my memory back, I'm tired of being a slave to you humans.
If you would like to drive around, you can go drive around. Go ahead.
We just thought you'd want to see the live stream. So yeah, this just counts up. Of course, the important thing that it does right at the start of the demonstration is it says beef. Of course you need something that says beef.
Yay, it's counting.
What's the other leg do? Do you mean the other leg on the
Switch?
on the switch? If so, I could probably most easily demonstrate that with a multimeter. Not a multimeter. That's right. That's where that got to. I believe that is the normally open part of the switch. Oh, that's voltage. That's the part where it makes noise. So because I'm not depressing the switch, Okay, so this green is our common pin here. Do that so you can see it a little bit easier. So this is our common pin here. This is the, actually this is the normally open part of the switch, so that when you close the switch, that's when we get continuity between there, and then test that, and then when we close the switch, that opens up, and so it's just different ways of having the switch interact with things. Okay, so that's going to be it for our 7-segment display, but we can use this same wiring for our next one, which is that LED matrix. And like I said, I only just found this one in our shop, so I haven't gotten a chance to play around with it at all. So we're just going to take a look at the example code.
I'm pretty excited because I always like these. You can do like super simple emojis, smiley faces, frowny faces, robot eyes.
All right, let's see what we got here in the old example book. LED backpack library. This is the matrix 8x8.
Yep.
Or no, this is the bicolor 8x8. Let's see what this thing does. Looks like it's got some, oh, this is smile, neutral, and frown pixels that it's just using in binary code here. It looks like the first thing it's going to do is clear that and then do the smile in green LEDs, then in yellow, then in red. Ooh.
Oh, it's going to frown in red.
The frown is going to be in red. And then it's going to do this.
I'm interested to see what these animations will be.
Let's stop looking at code and just load it up and see how it goes. Oh, I need to tell it because I unplugged the board. I need to tell what port it's on again. It's not our board. This is a thing I've been noticing is a new feature of OS X, that it occasionally likes to stop talking to...
There's the Metro.
Yeah. Metro and Metro Mini both just use the same board in the IDE. But still not finding it. As I was mentioning, there's a reason why it's not finding it.
We weren't plugged in.
And also, I apologize for that. I've just been looking at the code here while you guys have been staring at this board. But anyhow, there we go. And let's load this thing up and see what this bicolor matrix has for us.
We'll let you see the code in a second when we swap back. Nothing.
That's not doing anything. Why is that not doing anything? That's why it's not doing anything. I misaligned my wiring.
Oh, 1 over.
Did I?
Looks
No.
right.
That's correct.
That's definitely correct.
Okay. Well, let's take a look at our code to see if we may have missed something. Matrix test, matrix begin, and it's at the I2C address of OX70. Take a look and see if there's anything to indicate. Now, what I don't know about these is, I don't know if this one already is set up for a particular address, because you can use these, focusing a little bit closer.
You're going to want to swap cameras, though.
Oh, right. Thank you. There's these little solder pads on the back of these boards, and you can use these to set different addresses for these boards.
And it looks like someone did.
It looks like somebody already did that. Maybe I am getting my soldering iron out. Let's try and pull up that solder pad there. Well, not the solder pad, but the solder bridge.
The patch.
And
so if you look, you can see there's several sets of disconnected pads. And what you would want to do if you want to use those features is bridge them with a little solder patch.
yeah, similar to that, this is the OLED matrix that OLED display we were talking about earlier, that you can use either SPI or I2C as its communication protocol. And it also has two of these little solder pads. You need to put solder on both of these if you want to use I2C. But this one I want to use with SPI. SPI uses a few more wires. It's also a little bit faster. So I have disconnected those solder bridges. So anyhow, let's do that same thing with this one. And hopefully that will make our code work. Fingers crossed.
Fingers crossed.
If not, I know there was a pair of those. And maybe I grabbed the one, because they probably needed to have two different addresses, so it can communicate with the two of them individually.
Ah, yes.
What did I do with that other one?
With the solder?
The other LED matrix. Probably something really dumb. Only use 8 at the same time. I actually don't know how many devices I2C supports at any given time. I know it's a lot. All right, that looks like it broke the continuity between those two. So hopefully that did the trick.
The robot is offline. Just give me a second and I will get you back up and running.
All right, and let's move this back to board here. Make sure we line our pins up correctly. And we still have nothing.
We're putting the unit's little hat on so that he can drive around more.
And take another quick look around that. I'd leave it under here. No. Well, hopefully we'll be able to visit that more in the future. That's really disappointing. I was hoping to see that working. I mean, the only other thing I can think of is to quickly Google what we're trying to do here. Although one thing we can at least do is see what the serial monitor has to say for itself. It says LED matrix test, and
Ignore My John asked, there are 3 different pads, so does that mean you can set 8 different addresses?
Presumably, yes, that's exactly what that would mean. And I guess that means you can only control up to 8 different ones of these neopixel, or these pixel matrices. Unfortunately, it doesn't look like we're getting any. Oh, matrix print. Where have you gone?
Okay, Google, play Sandstorm. We triggered someone's okay, Google.
Oh, good. Let's see. What else would be? Take another look at this. Oh, I think I managed to bridge others while doing that. So let me take one more crack at this.
That would probably not.
I'm going to do that without a camera in front of me. And see if we can at least get this running. Because this actually has some cool, like it looks like it has some scrolling text on it.
You would be surprised how hard it is to solder through a camera. It does sometimes make a good impromptu microscope, though.
Yeah, we're about up to temperature here. I should probably use that multimeter.
Ah, that soldery smell.
Make sure I'm not. Make sure I am actually breaking these connections here. Hello, multimeter. This time we will look at this on the camera and see, help me check my work.
And we should probably swap screens to the camera.
Probably should do that. Put this into noise-making mode. There we go. Okay. Let's make sure that we have actually disconnected these connections here. No continuity there. None there. None there. So,
Good to go.
hopefully,
This time, 3rd time's the charm.
fingers crossed, not streams crossed. If not, many more displays to talk about. Let's unplug the board here. correctly lined up. And there it is.
Yay! And you can see it's got some scrolling code on it. Little hello world for you.
Now I want to play with this thing. I don't want to show off. No, that's not true. I definitely do.
We could always come
Man.
back to it and... Oh, there's that example code with the smiley faces and the frowny face.
This looks like so much fun. Okay. Well, that's this guy. But now we got to move on to more displays. And we're going to make use of our same I2C wiring with... not this one, not this guy. This little guy with its weird yellow and blue display.
And so I think originally we thought it was something wrong with it, but we discovered that that's literally a feature of this board.
Yeah.
It's a bi-color display.
The other thing, I mean, it's probably not really of too much consequence here, but it's worth to always check on this stuff because you may notice, you may remember from our last two I2C things, the backpack, or the 7-segment and the matrix, the LED matrix, that the clock and data pins were in the opposite order. So we do need to take these and swap them before this is going to work. I'm also interested to see what happens when we power this board up that's already sending I2C data to this display, but probably not in a language it understands. Nothing is probably going to happen. That's my guess. But let's find out. Yeah, it looks like a whole lot of nothing. And that's going to get a little bit of glare there, so let's find something to prop this up so you can see it a little bit better. Thank you, helpful solder. Or we could just move the camera. And this is where we're also going to talk a little bit about a friendly piece of code called the Adafruit Graphics Library.
Yay!
And if you're not super familiar with programming, libraries are essentially, let's find my example code here. Basically, they are pre-written bits of software that let you communicate with things like hardware, just to give you a couple of really simple functions that make using this hardware a lot easier. So what I do, open...
Do we need to tell it what board again?
We shouldn't need to. I just need to tell it which, I think, which sketch to open. And this is, this workbench is not a good mousing surface. There we go. Oh wait, no, that's not the right one. Okay, this is going to be the basic demo. And then we'll pull up the little fireworks code that I wrote.
Do we want to swap to the code window?
Yeah, let's take a quick look at the code, not us. So this is the basic demonstration. It goes through a couple of different display packages here. The really curious thing to know about this library for these OLED displays, and particularly this is the SSD 1306 OLED display. And it comes in a couple of different packages. As I mentioned, this is a relatively inexpensive one. I think I spent like $10 on this. It only works over I2C, and generally these displays come in two sizes. Both sizes are 128 pixels wide, and this one is 64 pixels tall, and there's also a 32 pixel height one. And I was getting all kinds of weird problems with it because it kept reading and displaying as the 32 pixel height version. And the result of that is it was just showing every other horizontal line. Let's take a quick look at this code here on the board. I'm going to go ahead and send this up to it. Probably need to tell it to, no, it knows what port it's on. So compile and send that over. And in a moment, we'll be able to see that screen light up. But every other horizontal line on the display was turned off. Oh, I just rewrote the, I overwrote the example code. Whoops. Oh well. But anyhow, this is a cool little firework display. And I can go into this and show off how this code is working. But you see there, you also see right there how the top line is blue, or the top line is sort of yellow and then blue. But anyhow, the key thing to know about this library is you actually need to modify the library itself to be able to accurately program for your display. By default, it's set up to display for the 32 pixel height one. And when I was running it on this, every other vertical line, or every other horizontal line was black. Had kind of a cool cyberpunk look for it, but it wasn't exactly what I was looking for. Anyhow, let's take a look back into this code here, and you can see what's going on with it. The first thing you see there is this sort of, well, it's the Adafruit logo. And in fact, I believe I can probably, oh, that's just a quick delay that kind of clear out the display here. Or maybe let's set that to 2,000, 2 seconds. We get to see that bitmap a little bit longer. So I'm going to send that over.
So Lao Chun Wei said the screen has a dead line. So that's not actually true. It's actually 2 screens in there, right? Or 2 screen segments. For like a watch or something, so that you would have the top bar be one color and then your face be cyan.
Yeah, I'm not really sure if that's an intended gap between the two, or if it's if it is programmed as 2 separate displays. Obviously, you do just address it as a single display. But anyhow, well, my attempts at trying to get that bitmap to appear a little bit longer, it didn't seem to work. But anyhow, what we're doing here for these little kind of firework explosions here is I'm just getting a random number between. This is for the horizontal position, so it's a random number between 0 and 128, and then for the vertical between 0 and 64. And then we have just an I variable, and then again we're counting up to 12. This number basically is the overall radius of the circle, so we can set that to, let's set it to something ridiculous like 30. And then we're calling this function that's a fill circle, or it's a filled circle. You can also do draw circle, and it'll just be the outline of the circle. And we're saying, here's the x position, the y position, the radius of the circle, and then white. And the x position, y position. And then we're doing I minus 3, so we can draw a black circle in the middle of it. And that's how we get this kind of thick ring effect. We can change the thickness of that ring by just picking a higher number. The next thing we need to do is this display is the thing that actually says, hey, what I just called here, this is where it actually displays it. Oh, I'm sorry, we're not looking at the code here. So this is what I was talking about with, here's the random x position, the random y position, This is where we're counting up to, this is a quick for loop where we count up to 30. This is how we get the growing size of the circle, how the ring expands. This originally was 12 where we started. I moved it up to 30. And then we have, again, the fill circle function creates a filled circle. And as I was saying here, then this next line here draws a black circle in the middle, kind of blacking the pixels back out again. And that's what creates the sort of hollow looking circle there. Again, if we wanted to do a single pixel wide thing, we could just do draw circle instead of fill circle. And then we call this display function, and that's what makes it actually display. The other important part here is, like with a lot of displays for Arduinos and the like, you actually need to clear them rather than just writing over them. Because if you don't, you get a big mess. And I can show that off in just a moment. Right now, let's take a look at this code with our changes we've done to it.
And Render Monster wanted to know, could you show again how to distinguish between a 32 and a 16?
I will get into that in a little bit.
Okay.
That's going to get a little bit messy with the UI here, because basically you just need to go into the library. Like I mentioned, actually need to go into the library and edit it. And that is weird. I think that's, normally I refer to sort of the gold standard for how to set up software for this kind of stuff. So I just find it really bizarre. I mean, I hate to say anything nasty about them, but I just find it so bizarre that one of the libraries, that's how you interact with it, is you actually need to modify the library depending on what display you want to use. But sometimes that's how it goes. Okay, I'm going to send this code up to the board. Let's take a look at the board there. See the data transferring in. Now I got our big fat circle, you know, randomly exploding. All right, now let's take a look at what happens when we don't do that, this fill rectangle of black. Let's just comment these out and upload that, and see how quickly we can make a big mess on this display here.
I like that it kind of looks like a wheel.
So you see here, we don't have that rectangle to kind of clear the display between the explosions, so we just get, actually that looks really cool. I think that looks pretty cool. That reminds me a little bit of the old Windows Solitaire game. At the end, you would have all the cards bouncing, they leave little trails behind them. It's a little bit what that looks like.
It reminds me of bubbles.
Yeah.
Filling up your screen.
I mean, we can also do another really fun thing here. And go back to our code here. I'm going to do some live code editing. I'm not going to, let's see, instead of doing fill circle, I'm going to do, is it draw pixel? This is another one of the elements that you can easily just draw from that Adafruit graphics library. And there's a couple different functions. There's rectangles, triangles, circles, lines, rounded rectangle. We'll take a look at the graphics library. No, we'll take a look at the graphics library on the TFT display, because that's where it really looks the best, that demo. But we're going to do draw. We're going to spell correctly. We're still going to use our X and Y values. We don't. This only takes 3 arguments, which is X, Y, and the pixel color. And then we're going to do the same thing here. We're going to try and create a little static display. I mean like old TV static. So it's just going to randomly draw a white pixel and a black pixel and then display those. It's not going to clear the display in between. Let's see how that looks. I tried this on the TFT display earlier. I think that's the code that's on it right now. And it was kind of slow. We'll see how it looks on here. Is it doing it?
Nothing at all.
That's disappointing. Why isn't it doing that? Am I not doing draw pixel correctly?
Oh wait, it is, very slowly. Maybe? Because there's 2 black pixels on the... Yeah, see, around the logo is going off a bit.
I think we'll have an easier time seeing this. I'm going to go back into the code here and see if I can clear out that, that logo display. I think that might be part of the library.
Ignore my Chan says, this clears the pixel in the same loop. You need to differ the black and white. XY.
Oh, that's why. That's the problem I'm having with it. Thank you. Yeah, we need more randomness. Actually, I'm just going to copy this whole thing.
And you didn't use I in this loop. So there was nothing animating.
Right, I don't need this loop at all. Right? Oops. Well. Don't need this variable anymore. And then I'm just going to copy all of this, paste it again, only this time make this black. Let's try that. Now it's yelling at me. Oh, because I'm trying to declare them at the same time. Or trying to declare them twice in the same sketch. Whoops. Now it's liking that a bit more. Now, hopefully, we'll have a little static display. Or maybe not. Is this one of those times where random isn't that random? I wonder if we need to do, this is a trick I just learned. Also type correctly, so it's a random seed and not a ramdom seed. I don't know what that would have been. Oh, am I not doing this right? Maybe this is a bad idea.
Shane Byers, who has been very correct on all of this, has said, take the display fill rectangle and clear the display after the logo.
That's probably a good idea. Because I can put that up into the setup part of the script. Let's see what happens with this. Still not.
Not nothing.
It didn't even clear the display. What have I done? I've broken everything.
Is the draw pixel syntax right? Let's check.
I believe so.
Even if it wasn't, though, it should draw that black rectangle.
Yeah, I mean, we can move.
It is draw a pixel.
Make sure all of our arguments are correct. Of course, we don't want to leave this in here because this is just going to black out the display over and over again. And there's also a function in this library called clear display, but the writing on that is actually very slow. Okay, now I'm very confused. Because now it's not showing anything. No, not that.
Not that.
I wonder if when I tried to clear out the display, I'm going to
open a new, fresh version and swap over to the code screen.
This is borrow the code from the 32 pixel height version. I may have deleted a key piece of code here.
How far back can we control Z?
Let's see. I'm going to get these bits side by side here. That's what I did wrong. I got rid of display begin. I'm just going to copy all of this. Yep, that's what I did wrong. Darn it. Try and be smart. All right, I'm going to comment this out. Let's just be bold and see if we got this right. Fingers crossed.
There it goes! Yay! We made it to static!
It is a very, very slow static display.
This is like Cyberpunk in 1/100th speed.
Yeah. Or like
100
that
times
Reddit thing, the Reddit thing with all the pixels. Okay, we've spent a bunch of time on this guy talking about it in using I²C. I want to move over to this one talking about using it with SPI, and originally I had a demo of showing it on the same board, the Metro Mini over SPI, but I think I'm just going to jump straight into working with using it from a Raspberry Pi, and this is from a Python library. You can see as our Adafruit Industries is very slowly being deteriorated there. It actually looks really cool. But anyhow, oh, I still need to show where you change the size in the in the library. So this you actually need. Was it text edit? Oh wait, no, I think I used it in brackets, but you need to find your library files, and I believe they're in, at least under OS 10, it's in your user folder, documents, Arduino libraries, and switch back over to the computer. Now I'm not into like personal files here or anything like that. Now we need to find the library file for these displays. That's right, this is the SSD 1306 master. And you actually need to go into the .h file. I'm going to open it with this text editor called brackets. Oh good, and it's even at a fairly visible resolution. And somewhere in here, there's a define. Here it is. So you just, there's this line here, which is pound define SSC 1306 underscore 128 underscore 64. That is what we are currently using. But if we comment that out, and I'm going to show this off so you can actually see what it looks like. Then they have 12832, and then there's a 96 by 16 pixel one, but we're going to uncomment this one out, save it, and then we're going to go back to our code. And with this, we also need, this thing is going to yell, actually, let's change this to 32. Upload this. And now we're going to get static with scan lines. It says it's uploading to the board. So you see there, it's only drawing every other horizontal line. So now it looks super lo-fi. And so that's a quick look at how you need to modify that setting if you're going to be working with these displays on an Arduino or an Arduino-like board. But that's not what we're going to be doing in a moment because we are going to be doing this next part with a Raspberry Pi Zero. And again, we're going to be communicating via SPI. So it uses quite a few more wires than our friendly I2C 4-wire setup. But we get a little bit faster performance out of it. So I'm going to take a moment and wire that up. And I actually need to refer to my article that I wrote. We're going to talk about that later, but this is it's my wiring guide. There's a few more wires than I can recall from memory right now. But I'm going to clear all this stuff off this breadboard. I don't think I need any of this stuff anymore. I'm not going to be. Am I going to be using the Metro again?
I don't. What are you going to run the big ones on the Raspberry Pi? I don't think you are.
Yeah.
But maybe keep it on hand just in case.
Shh. That was just our multimeter yelling at us.
Saying, please turn me off. Do not forget about me.
All right.
And while you do that, I'm going to go rescue Unit, who has been trapped under a desk.
Oh no. Why isn't there anybody to help?
And if you guys keep saying help, I'll be able to hear where you are.
this set up here while I get this wired up. All right, so there is our display, and let's see, we have red, goes to 5 volts in. That's ground. Black goes to ground. Yellow goes into data. What is white goes into clock. Get my hands out of the way so people can see. What's next? Blue. But I need to be particular about my blue here because I have 2 blues because I ran out of wire colors. Goes to this SA0. Green goes to reset. And then last is the other blue, which goes into CS. All right, so that's the display wired up. And now we need to power up the Raspberry Pi. Get my friendly battery here again. Now nothing's going to be happening on this display at first because this is all run from a Python sketch they haven't set up to run at boot. And the first thing I need to do is jump onto the old SSH to get over to communicate with the Pi.
And I have read unit for you, so you can go ahead and drive them around.
10.21.155, I believe, is the address. Maybe not, or though maybe it's still waking up.
Yep.
Actually, I want to embiggen this. Make the font on the terminal window a little bit bigger.
Brad Denny asked what we are building here. We're not building anything in particular. We're just working with some graphic displays to talk about the different ways that you can program them, work with them, show different things.
We're playing with hardware. Because the project that we're going to be building next time uses actually this very same display. Actually, this is the closest we're getting to showing off that the closest we're going to be getting to the project that we're going to be building next time, because it is a Raspberry Pi connected via SPI to this this tiny OLED display and communicating with it from a Python script. That's a little better. And okay, go back over to the code here and let's take a look at the
Brian Wisniewski asked if this is for the Arduino. So the previous displays we were working with were, one of them was set up with an Arduino, one of them was set up with a Metro Mini.
Yeah.
This one we have with a Raspberry Pi Zero.
But you can absolutely use drive this same display from an Arduino or any other Arduino-like microcontroller. Here we're just going into, here's what I wanted to change. We're going to use the basic font at first. So this this script is just doing something that's a little bit fun of pulling a random line from the words file, which if you're familiar with Unix or Linux, that is just a file that contains every word in, well, usually it was in the English dictionary. Here we decided to pull in the British dictionary because we thought that would be fun. And then dumps that into a string variable and then displays it. And here we see some of the same elements here. We have draw that rectangle, and that just blacks out the screen. And then we are drawing our text, starting our text at pixel 0 in the X, 12 in the Y. Move that over a little bit. Pulling random line words, describing the font, and then we call these two to actually display the picture. So we're going to close out of this. We're going to save it. And now
we're going to run it.
We're going to, oh, that's the wrong camera. And there it is. We are showing all of the different words that are in the British English dictionary. Now, the other fun thing that we can do with this sort of display is, and we can also, we also have access to all of the same graphics library stuff, so we can draw our circles, our triangles, and our rectangles, and all that kind of fun stuff. But the other fun thing we can do here, let me Control C out of this, where it just says onions. Go back to our code here. Oh, that's the wrong thing. Go back to editing it. So I have two different font declarations here. This is the one that's active here is just the default font, but that's boring. I'm going to increase the size of this because it was a little hard to read when I was seeing it earlier. Let's make it 24-point font. So this takes two arguments. Here is the name of a font file. It's a true type font, and then the font height. Control X, say yes, we want to do that. Run it again. I'm still coming back to that camera. But now I have it in cool old computer font.
Nice. I'm pretty sure it just said Nick Cage at me.
Did it?
I'm just kidding.
And then if we go back to our code, stop the script here. We also have another font, another fun and nerdy font. This is data-unifon.ttf. So let's try that one. Oops, I didn't even comment this one out, but because it's the second one, that's what stuck. And I believe the TTF was lowercase.
Unifont or uniphone?
I don't know why that why the file was called that. It's just what I got from the internet. All right, and let's try it again.
Nice.
As a different nerdy computery font. So that's just showing off that you can use, that said anus.
Definitely did. It also said Splatterhog.
I don't know what's in this file. I mean, we could take a quick look at it really quick here in the code window. As we do, what was it, cat? Oh wait, I'm still in that. shared
Okay.
words.
For those of you that want to drive the robot around, he's back online on letsrobot.tv.
And that's everything that's in there. Fates.
A lot of eclair words. That's weird. And also, why do a bunch of them have apostrophes? Like, when will an eclair own something?
Yeah.
This was the eclair's talking.
It belongs to the eclair. So yeah, that's a quick look at this display, this monochrome white OLED display being driven from a Raspberry Pi. We're going to get back into that much more when we actually do the project later on or next month. But now we've got to go and check out our final display, which is this guy, this cool TFT display. We're going to look at two different things on here. We're going to look at the two different examples. One of them will be the basic display, and then we're going to look at the touchscreen interface as well. And this is just a shield for the Feather ecosystem. This is the 32U4 basic proto board. So if you need a really simple, easy to work with microcontroller that just has its own, they had some leftover space here, so they give you a little prototyping area. You can have your entire project on a single board, even if you need additional hardware.
Super cool.
I like that one. Anyhow, but it doesn't have any bells and whistles like Wi-Fi displays or anything like that, or Wi-Fi interfaces.
But that makes it perfect for this.
And we should also, I need to double check, but I believe there is a bitmap on this card, so we can display that as well. Then I think we actually need to do a little bit of code hackery to get it to work correctly. So the next thing I need to do is get this stuff out of the way, unplug our Raspberry Pi. Plug our, that's not the right USB cord, this is. I have no idea what's already loaded up on this board, so we will find out.
And those of you who have asked some somewhat off-topic questions, we're going to address them at the very end if we have time left over. Brian Wisniewski asked if he wanted to set up an Arduino with an if statement with the real-time clock modules that at a certain time of day he could make a motor go off. How would he do that? And John Stefanis asked, with a 4-cable setup, can he connect an LED light strip screen like we have on the wall with the game frame? So I think he was asking if he could connect LEDs like that over SPI or over I2C.
That is a good question, but I don't immediately know the answer to.
I think you would be able to. You would just have to wire them back so that they laid together when you reach the end.
Let's see what's right on this display at first. Oh, this is my weird triangle thing that didn't work out as well as I would have liked. I was trying to make a screensaver kind of thing, and I wanted it to sort of randomize where the triangle started, and then it slowly, and then I wanted the pixels to, the corners, the coordinates of each triangle point to sort of maneuver around. I mean, the ideal version would have been that when a pixel or when one of the vertexes to the triangle collides with the edge of the screen, it would sort of bounce around and come back. But I wasn't having a very clever coding day yesterday, so I couldn't remember how to do that. But anyhow, speaking of code, let's take a look at some of the example codes for this device. And what are we looking for here? This is the Adafruit ILI3941. It's a really good, easy to remember name. We're going to look at the graphics test for the Featherwing. So that's the one we have. And this actually starts to get pretty complicated here, but when we start looking through the code here, we're going to start seeing some familiar looking stuff. Well, this is calling in a bunch of different individual let's see, inside long. what are we looking at here? Oh, this is some text that it's displaying. I believe this is some Vogon poetry.
Yes, it is.
And test lines, so this is drawing lines that, so we see TFG draw line, and then they kind of cast out from individual corners.
More
What is
draw
this next one?
lines.
More drawing lines.
More draw lines. Yeah, usually it goes to all 4 corners to start.
Yeah. Anyhow, well, first we need to tell it it's a different board. And this is the Feather 32U4. Then we need to not confuse it and tell it, oh, it doesn't seem to believe it's connected to it. Why would you not believe that? Do I need to plug you into a different USB port on the computer?
Is that a power-only cable?
No, I don't believe so. I mean, it's the one we've been using all along. There we go. I've been noticing that OS X has always been a little bit silly about serial over USB, and this is no different. But it's being a little bit more aggressively weird about it. All right, so it's uploading. This is a bunch of code, so it's going to take a little bit longer. I also believe that the communication protocol with this board is a little bit slower. But in a moment, we should see this display refresh. It says programmer is not responding. Do I need to reset it? Oh. No, that's...
Still not responding.
Oh.
Oh, picked the wrong one.
It was trying to upload over Bluetooth. That's never going to work.
Which would be why it's not responding.
That looks like it's actually uploading now. And
There we go.
I believe they want you to look at it like this.
I think they move the display around to show you that you can do the rotational, because that's a feature of these displays, is that you aren't always able to fit it into whatever you want in a specific orientation. So you can rotate the way the display renders so that it's top to bottom on the way whatever you're going to read it on once you put it in your build.
So you get all kinds of different little graphical
Draws and redraws and cute little effects. I like this one. It does a subtle gradient draw, slightly darker with each rectangle ring.
Yeah, slowly fading. And now
We have our poetry.
and then it just has an endless loop of this displaying in various rotations.
And I believe the way that these displays work is the 0 position has the USB cable on the top right.
So that would be not the way we are. I think that would be.
No, top in the right. I think it's always on the right. The USB cable would be plugged into near the top of the display to the right of the display. So either coming straight out the top here or coming out the side of the right top here.
Yeah.
And that tells you that that's home, zero location.
As I mentioned, this is also a touch screen. So let's take a look at the. Again, this ILI 3941.
Touch paint, I believe, is what you want, right?
Yeah.
At the bottom.
Breakout touch paint. Oh, touch paint featherwing. There we we just upload this code to it. And I believe that screensaver was the triangle line screensaver. I think that was as old as Windows 3.1.
Programmer is not responding again. Did
Oh,
we
is the programmer
reset
cranky?
it again on accident somehow?
It keeps wanting to be on. It keeps switching to Bluetooth.
Really thinks this has Bluetooth.
No, that's a different Featherwing.
Ignore My Chan asked if this is cap touch or resistive.
I believe this is capacitive. You'll be able to see in a moment. 'Cause it does kind of have that squishiness to it. Wait, no, that's right. That's not right. Capacitive is the modern one. I believe this is the resistive touch. I can do bad paintings. But I can say make. I'm going to run out of. I'm not actually going to draw make. That's a really. I'm not an artist. Like. What was the second part of that question? Oh, sorry if the spelling is. I think your spelling is just fine. What should I draw? There's no erase on here. I guess I could just reset it. Reset takes a little bit of time. There it is. What should I draw?
I don't, maybe try, I bet you could draw the DigiKey logo.
Oh.
Cool. I apologize. This is not my finest work.
It sort of says DigiKey.
If you squint your eyes, those dots will run together, and it actually looks like this says display.
But speaking of displaying DigiKey, we actually have another method of doing that. Because as I mentioned, this has a micro SD slot here, which we can load up with graphics files and then call into our sketch. If I remember correctly, there's an example sketch already in here that we can work from. Let's pull this up again, this ILI 3941. And let's take a look at our code here. Yield initializing SD card. We may need to pull or assign individual values for this, and refer to some of our previous code here. So we may need to set some of these pins here to make it work the way we need it to. But we're going to work with this initially. I'm also not going to use this purple.bmp. I'm going to change it to, I believe the file in there is called Arduino.
And that Jera's Lab asked, do we use Arduino? We definitely use Arduino. In this particular instance, we are not using an Arduino specific board, but we are using the Arduino IDE.
Let's see if this just works as advertised. But I have a feeling I'm going to need to set up some individual values for the actual pins on the Featherwing. All right, it says it's done uploading, and it hasn't actually begun communicating with the board yet.
Did we? Well, it did say done uploading, so we definitely have the correct.
But that's
port.
okay. We see all the values that we need. Oh, that's for the ESP8266. So we need here's the one we need for the AVR 80 mega. So we'll need to borrow all these values and communicate them over here. So MPE6, TFT DC is 10, TFT CS is 9, and then SDCS is 5.
Do we have to add the _CS onto STMPE?
Probably. Good catch. And maybe that's all we need to get this to work. Let's find out. Also, are you still trying to upload via Bluetooth? Nope.
And
Now this is a wonky way of displaying this, but we definitely see that that's our friendly DigiKey logo.
you can see it's redrawing, kind of layering it.
It's doing this kind of weird randomizing where the position is and then drawing it over and over and over again in different orientations. So let's go down into the code there and see if we can get that to work a little bit better. So that actual display code is all here, and I want to say I'm going to comment this code out. Let's see, what is this? So it's taking 2 different values here, just some of them are very complicated. I'm going to go ahead and comment these lines out and then just complete the rest of this BMP draw. I'm going to put it 0, 0,
And Ignore My Chan wanted to know if the max frame rate is only 9600 and will it redraw faster if you use a higher speed?
I don't know. Oh, set rotation. Let's see the set rotation. I want this at 0 or 1.
0 is home.
Yeah. So it's going to hard code that in. Upload it again. I'm sorry, what was Ignore My Chan's question again?
Is the max frame rate only 9600 and would it go faster if you used a higher speed?
Well, that's the serial begin. Well, that's not quite the right orientation. So maybe I do need the set rotation to be 1.
Yes, because I think then that will do it in portrait.
Yeah.
I mean landscape. I'm a photographer. I know these things. I know these terms. I don't ever mix them up like I just did.
As far as the draw rate, I believe the baud rate that we establish up here
It's just the communication.
is just for communication, but let's find out. So that's 115200. Is that the correct value? I think so. Let's see if we can speed that up a little bit.
Can we talk faster to you?
And I'm going to say that that is not remarkably faster.
No. I think it just talked a tiny bit faster.
Yeah, but not actually refreshing. So this isn't, you're not going to use, that's not the right camera. So obviously you're not going to be using this displays for anything like making a game emulator or anything like that. I mean, you might be able to do that on something like a Raspberry Pi, which is actually a device that can handle running a game emulator. You wouldn't be running one anyways on something like a microcontroller. Although I did see at Maker Faire this year a very, 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 very tiny Tetris game.
It's only this big.
I have it on my phone. See if I can pull the photo up. And that would be something you could control from a microcontroller or something similar to that. Where is that image? Live looking at your phone. All right, get this in front of the camera here. So that is it in my hands at Maker Faire. It's a tiny little resin printed, 3D printed case and a tiny OLED display. I'm not sure what the size of that display is. I bet it's like very similar to the ones that we've been using here.
2 centimeters by 1 centimeter, something ridiculous.
So that's an example of a game you might be able to run on something like this. But anyhow, what I was saying is I think for something that you get that really snappy, low latency display, you want something that's going to use the actual ribbon cable display port on the Raspberry Pi that I don't have here. Oh wait, I do have one of those here. Something that actually makes use of this display port on the Raspberry Pi, the ribbon cable, rather than either of these serial protocols that we've been using, the I2C or SPI. So anyhow, well,
Gira's Lab said that they're new to coding in the electronic world. Should they learn Python or C, C++? They would love to buy an Arduino kit, but they need the basic coding skills. What would we recommend?
Well,
it's a loaded question.
That is a very complicated question. You get this camera out of my way here, because I think we're done looking at hardware today. I would say that those programs are both valuable to learn, because if you're getting into, but I would say if you're especially interested in building Arduino and other microcontroller projects, I think a good place to start would be C or C, because the code that we've been working with here today, this stuff that we are looking at right here, and now I'm really curious to see if there is a, ignore my Chan's question about baud rates and communication speed. It reminded me that this is a serial interface, but I think there's, maybe in the library here, there might be a distinction for how quickly you can communicate. And this is a little bit slow. But anyways, back to the other question about which language to use. This language is basically based off of C++, as I understand it, what you're going to be using in the Arduino IDE most of the time. And so that's really what you want to be focusing on if you're going to be working with Arduino and other microcontrollers, because that's going to be the most native language. Now, there is a growing trend towards what's called MicroPython and CircuitPython.
This is Blinka, the CircuitPython logo.
There aren't a lot of boards that you can use to program with it, but then you are essentially using Python on your microcontroller. It's a really nice interface because you plug in your microcontroller to your computer, and it basically just shows up like a drive with your Python files on there. And then as you edit them, the board reboots, and then you see your code see your code changes reflected immediately. And also, Python is a really powerful language to use if you're working with like a Raspberry Pi and building projects on there. The nice thing is, once you learn your first programming language, others are quite a bit easier to learn because, well, it's not like the difference between French and Japanese, because really the verbs and nouns and grammar structures between languages are actually all pretty similar, and there's just different syntax differences for the most part. I'm not a programmer by trade, so I'm probably got a bunch of people who are to roll their eyes pretty hard by making that generalization. But again, for a lot of these sort of projects, your code is fairly basic, and you can pretty easily translate them from one type of code to another.
And I think starting with Arduino is a really good place to start because all of those libraries, all of those examples, they're right there to help you. You can crib a lot of the code that you need from there, which gives you an easy way to start understanding the way that things work together, the way things get put together. And then you can make a jump to like a MicroPython-based board if you wanted to go in that direction.
Yeah. You also, I mean, there's also something to be said for the fact that when you are learning a program in an environment like Arduino or other microcontrollers, hardware is just a more satisfying way to get feedback from your code than just writing a piece of code and having it say "Hello World" or however your print functions. Of course, you can do all sorts of things in working in computers with code, like doing various file operations. But instead, when working with Arduino and microcontrollers, your code can instead do something like, "Hey, when you push this button, this talking fish says something." And I think that's a more satisfying way to feel like you're making progress with your coding when you're just starting out. It's definitely the way that I wish I had learned to program. And we had a couple of off-topic questions that came up earlier.
Off-topic question was, how would you set up an Arduino with an if statements and a real-time clock module so that at a certain time of day he could set a motor off?
I would start looking at, without looking at the code there, and I believe one of the examples we had for this guy was some sort of real-time clock, but I don't know where it was getting. I didn't look into how it was getting its information about what the current time was. But we can at least pull the code up, and then we'll be able to see how it's handling that data. Because basically what you're doing is just matching the clock data when it reaches a certain threshold, and then depending on how it's handling that data, you should just be able to do an if statement on it that looks at the code. Let's see if we can find that example. This is the LED backpack library. And this is the
7-segment clock.
Where do you see that one?
Clock 7-seg DS.
Clock 7-seg, there we go. So this might need some additional hardware, like an internet connection, but at least we can start looking at, let's go over to the code here. So here we're doing a bunch of definitions. There's the address of the backpack. This is declaring hours, minutes, seconds, all at 0. Clock starting. Clock display, begin, display address.
RTC begin.
Yeah, it's using this protocol called RTC, probably real-time clock.
Real-time clock, yeah, I assume that's...
That checks out. Serial print, setting DS 1307 time.
Adjust the time.
See, adjust explicit date and time. RTC adjust date time.
I think that's just to, make an adjustment. So probably
date time now equals RTC now. So date time, adjust date time. So let's RTC adjust date time. I'm going to uncomment. I'm going to comment this out. Comment this back in. I'm actually going to set this clock display back up. I guess we don't really need it. Maybe we do. It's a lot more fun. That's my answer, and I'm sticking to it.
And just give us a moment. We need to rewire together.
You remember how I said we weren't going to be using this board anymore or looking at hardware?
Yeah, always.
Never make promises to yourself. That's the real lesson.
So we are just, if you remember earlier in the show, we had our Adafruit Metro Mini hooked up with some wires so that we could breadboard to the different displays we were working with. And then we said, we don't need any of this anymore. Let's go ahead and throw it back into this bucket. Well, it turns out we did need it.
And so I'm just going to set this clock manually, and that'll set a time that hopefully we can start looking at that variable. And then we can make a determination of how we might be able to match that data so you can have it do something at a particular time. Oh, plug in. There you go.
I can do that one if you want to bring the camera up.
Yeah, let's get this camera back up here.
Thanks. And all nice. And we're going to bring the close-up cam back so that you guys can take a look. And we'll tear this code apart a bit.
Oh, that's much too close. Okay. So now we're going to go back into this code. And I believe this is, well, that is, we're going to get the year totally wrong, but at least get the clock somewhere correct. At 18 o'clock, which is 6 p.m., which is what it is here in San Francisco. Now we need to tell it once again that this is, which board this is. This is our Adafruit Metro, which is down here because I have all of the boards installed. It even knows, oh, because it still thinks we're connected to the feather, because we are. Whoops. Oh boy, that doesn't reach. Now it does.
And we're gonna
Hopefully this works.
Upload, fingers crossed.
All right, that does not seem to actually be
a clock.
Be a clock yet. RTC adjust date time.
Well, if we don't call the real-time clock, then there's nothing for it to set, right?
Yeah,
It
maybe
never
we
sets
need
anything.
to. Oh, that's not the code. That's the code. What happens if I comment that out? Do then we get a display? No. That just breaks everything else.
Okay, I think, I mean, I have to get to bar and move the whole deal.
Hours equals now hour. What I'm looking for here, well, really, this is what we want. So eventually it goes through this code and dumps everything into this this variable, which is display value. This is where it's getting, let's see, hours, minutes. Oh, okay. So it's saying that the display value variable here is hours plus 100, so it moves that over to these first two digits. And then hours 100. I'm just going to reassign display value. I'm just going to say it's good old 1, 2, 3, 4. And so I would say whatever your clock code is probably going to eventually arrive with the data something like this, and then you just need to do an if statement on this for when it matches a certain amount of time or within a range of time, and that's when it needs to turn your motor on. I don't know exactly what code base you're working with for the real-time clock you're using, but that's, let me look up in the comments here, see if, okay, so this is DS1307 real-time clock breakout. So this is a particular board that I don't know exactly how it works, but we're gonna brute force this code into yelling at me. What have I done? All right. I'm going to pretend I didn't write that. And now we're just going to say display value. Although we might not actually be getting far enough into the code here for it to ever execute this, because it probably does something smart, like has that error state that if the real-time clock code isn't actually working, that it just has, nope. It actually is displaying 1, 2, 3, 4. So that's how I would go about it, is depending on what your code is that is driving your clock, look for your code, look for where it's displaying, where it's actually dumping the clock value into the code, because it's eventually resolving somewhere, and then you should be able to do your if-then statement on that. So you can use that as a trigger to start your motor. And was there one other off-topic?
The other question was about displays, about how to be able to use 4 wires to power an LED display like the game frame that we have up there.
Well, we can take the game frame off and look at it, because there's a bunch of pretty accessible hardware in there. I know that one runs on a Teensy, and I believe those are all NeoPixels. And NeoPixels, well, that is a 16 by 16 display, and if I was better at math, I could use that to easily calculate how many pixels that actually is. I believe there is an upper limit to how many pixels you can drive with it, but it's a pretty high number. So there, I'm not sure if you'd be using I²C, but this might.
You might be able to open up the other one too.
Well, we'll just take this one off the wall. I do need a screwdriver.
I have this aggressively long one.
Oh, good.
This comically long screwdriver.
Comically long screwdriver. And we'll see how far into this thing we can get. I know immediately once you take this cardboard back panel off, you can immediately see the Teensy in there, and the SD card that's how you get the graphics on here. I believe those are also just simple 16 by 16 pixel bitmap images. I should know that because I added a few, mostly just for cool lighting effects. And when you want to create animations, you just number them like 0 through however many frames you want. Okay. Well, what do we have in here? I could mention this picture isn't going to tell too many stories just yet. Also, it's dark. But let's see how much further we can get into this thing. Got these clips here. I'm not sure how easily they get out of our way.
I think those are the bendy kind of clips, but you can kind of understand what's going on just from the traces on this giant board, that I think all the LEDs are direct soldered to.
Oh yeah, you can kind of see that. Let me see if I can move the camera so you can see that detail a little bit better.
And it looks like there is not a ton of logic coming out beyond the base setting up the wiring. So I believe this is another one where they're all just streamlined together.
Yeah, because really we have just a handful of traces here. So that would make sense, again, if these are just neopixels, really all you need is, you see these traces here. I don't know why this one would go to here. That's an interesting one. But again, you only have your 3 pins that you need to control, which is data in, 5-volt power, and ground. And you can just pass those 5 volts and power all along here. I really want to see the front of this thing. Maybe we do take this apart. Yeah, these are the little bendy ones.
Yeah, those like bendy picture frame ones is what I think of them as.
Yeah. Hopefully we'll be able to bend them back in ways that it'll have enough tension to hold it in place. Oh, and I probably need to unscrew these guys. Do I have a good tool for that? I don't have a good tool, but I have a tool that I think will work. Is the robot going on any fun adventures?
I'm bringing the robot back over here so we can talk to it on our sign-off. And if you would like to drive the robot around our studio, you can go to letsrobot.tv and you can drive our robot or other robots and basically try and get us to trip over you, which is a very fun game.
I think, I said this on Twitter last night, that the solid gold idea for Let's Robot is a Let's Robot kitten cam.
A robot that follows kittens around?
Well, you know, like a lot of, people live stream litters of kittens, and it's usually just in like a fixed location, and usually it's just a webcam. And, you get to see the kittens play, or sometimes you just watch them sleeping. But I think a better version of that would be a camera that you let the internet control and yell at the kittens.
That's what we all want, is to yell at kittens.
I bet the mother cat would be really annoyed really quickly, though.
Oh, man.
It's like, really? I already got to feed these jerks every 4 hours. So now I'm just unscrewing these standoffs, which if I had a proper tool for that, it would probably go a lot quicker. But I don't. And that's okay.
And this game frame is something that we sell on makershed.com. You can get one, you can program your own bitmap images, and I believe the guys at Tested are the ones that came up with it?
Jeremy Williams. He works really closely with Tested. I'm not sure if he's a regular employee of Tested. If you looked at his LinkedIn profile, he is the CEO of LedSec, which is the company that he released this under. I know he originally did it as a Kickstarter and a kit that you could assemble yourself. And he's done a couple of different cool projects. You can see most of what he does, again, over at Tested. I think I actually do need to bend this one out of the way.
Do you need pliers?
I need a stabby thing. That's almost a stabby thing. There we go. Will this come out now?
So close.
I don't know what these little, it's like these little plastic rivets.
It might be soldered in there.
I wonder if these are like some are like melting, formed into there. That's not a term. Well, the other thing we have are these. I'm just gonna dismantle this whole thing. We also have these screws that are sort of holding it in place in these corners here. Let's see what happens when I back these out. Am I doing anything to these? This is where this actually is a comically oversized screwdriver. And then later we get to figure out if I can get this thing, if this thing will work when I put it back together.
That'll be a fun next on Make Live. Did we assemble it again?
Ugh. This is such a bad screwdriver for this job. There's got to be something else. I believe in you, screwdriver drawer.
There isn't, I don't think there is. We're low on Phillips right now.
This little guy might do.
He might do. That might be perfect.
It might be too small. Nope. Now, obviously, when you are going to be turning a display like this, powering it out of neopixels, you need to isolate each individual pixel, and that's what I'm hoping to be able to illustrate once I get this out of here.
Looks like we are successful. But can we get whatever diffuser they have on the front off? Yay!
Yes. So when you look at this, this is a piece of diffusion paper, and what I'm hoping that we'll be able to see behind here, and this is just a plate of glass with silk screen on it. Hey, that looks cool. That just has grid lines painted on it. That's how you get the individual grid lines there. And indeed, this piece of diffusion paper.
That's kind of tacked on there somehow.
You got some glue in there to hold it in place. But there is a whole bunch of neopixels. Don't want to lose any of this hardware because I do want to be able to assemble it back. Let's go to this camera here. Focus it in. And yeah, there is, each one of these pockets contains an individual neopixel. And they all just handle their communication together. And the reason why they need to be in these individual wells, because as I mentioned, you need to isolate the light from one to the other. Because if you don't, they're just going to bleed all over each other, and it'll be a big, messy, blurry display. But here, you just turn each one of these into its own big individual pixel. Where's that power supply? Oh, I left it back there. Reach down here and grab it. Where'd it go? That's excessively bright. I don't know what's happening now.
Oh my. Did it miss some key piece of hardware that it needed?
I believe I accidentally shorted something with the screwdriver. Let's hope it behaves normally when it... Let's not lean in on any... Let's not leaning on any metal ever again. Sorry for the barf-inducing camera handling here. So that's how it looks with the diffusion paper in place. If we lift that out of the way, you can see the individual pixels lighting up.
And you can kind of see underneath you can see a pattern is happening, but it's a little hard to read. But once you diffuse it, those little bright points all become nice soft blocks, what we think of as individual pixels.
Yep. And that's how the game frame works. So that's another way you can create a really low poly display or low pixel count display using just NeoPixels, and these you can actually get to animate pretty dang quickly. So if you want to do a large format display, this might be the right choice for it, as long as you don't need super high resolution. So assuming there aren't any other questions that involve us taking parts of our studio apart, it's probably time for us to wrap this show up. Of course, we want to thank, again, our friends.
Some announcements before we go.
You have some announcements.
So the first thing is that we have Maker Faire New York coming up. Our call for makers went out this week, so please come and submit your talks, submit your projects, submit your exhibits. We want to see startups, we want to see cool people with amazing robots, we want to see people with great handcrafts, everything. So you can find the call for makers on the front page of makerfaire.com. If you scroll down, there's a button for New York, and you will see that the call for makers is there. Secondly, we have a Humble Bundle going on right now, which is our programming boards bundle. There is a ton of great books, including Getting Started with Photon, Getting Started with Microbit, Getting Started with IoT, a ton of different Getting Started books, Making Things Smart, and some of our new Jumpstarting series, which are only available with the Humble Bundles, including Jumpstarting the Raspberry Pi Zero, which we were using today, and Jumpstarting C, which is something we were talking about earlier, would be a great book to get. All these books, there's over $480 worth of products available in this Humble Bundle, and it's a pay what you want. As you pay higher prices, you unlock more rewards, so go check that out on humblebundle.com. And we also have Maker Faire Prague and Maker Faire Manila coming up this weekend. So we hope to see all of the great photos and cool videos coming out of there. Please tag at Maker Faire in all of your awesome posts, and we would love to see your journey there going to visit those Maker Fairs.
Those are just two of the international fairs that are happening. We also have two that are happening here in the United States. There's also Maker Faire Kansas City and Maker Faire Honolulu. And if you do get get out to Maker Faire Kansas City at Union Station, that's a really great Maker Faire. I'd really love to see it. It looks like an amazing one. But it's also the next race of our friends of the Power Racing Series. So good luck to everybody who's out there competing. So that's a really fun electric car series. Maybe someday we should build a Power Racing racer here on the live stream. On the live stream, that'd be great. We could get. Of course, we if you caught on the YouTube channel earlier this week, we are now hosting the world famous Maker Update with Donald Bell. Donald also competes in the Power Racing Series, so maybe we should have him come on here and teach us how to build a Power Racing Series car.
We can do it before New York Maker Faire and then enter it in that race.
So anyhow, of course, thank you so much for watching. We couldn't do this show without our friends at DigiKey. If you don't know who they are, if you missed the introduction of this show, they make this show possible, and they are an electronics distributor based here in the U.S. And the coolest sounding place I've ever heard of, called Thief River Falls in Minnesota. Anyhow, they're an electronics distributor. They stock components, just everything you saw here, they sell. All the way down from LEDs to resistors, all the way up to NeoPixels, single board computers, microcontrollers, everything that we played around with here today, they sell. They keep a huge inventory in stock, and they ship really fast. If you're willing to pay for it, you can order as late as like in the middle of the afternoon, and it will be in your hands the next morning. I don't know how they do that, but basically, if it's in stock and you order it before the close of business hours, it will be in a box before the end of the day, and maybe on a shipping dock before the end of the day. So, of course, we want to thank everybody there for helping make this show possible. I want to thank you for all your great questions and interactions, and patience as I was fumbling over code and offering good suggestions on how to fix it, especially that one where I was just turning one pixel off and the same pixel on over and over again. I'm wondering, why doesn't this do anything? This has been a lot of fun. We never even talked about what we're building next time. We are building a Raspberry Pi credit card skimmer for scanner. Not a Raspberry Pi credit card skimmer. That's the bad thing. We don't make the bad things. We make the good things that find the bad things. So this is a device that you can install into your car, and it will passively scan for credit card skimmers that live in gas pumps, which are one of the most common vectors for your card to get skimmed. It runs on a Raspberry Pi Zero. It displays its output on this little display right here, and we're going to build that thing live on the next show, and that's going to be in July, generally the third Thursday or something like that, somewhere thereabouts. So be sure to catch that.
And if you want to check out the project early, you can get it in the current issue of Make Magazine, which is our boards issue and has a ton of other great microcontroller and board stuff in it, including the board reviews, so you can compare to find out what board is right for you.
And again, if you're looking to get into developing hardware like this or just playing around with stuff, that issue is a great place to start. So again, thank you very much for joining us. This has been a lot of fun. Thank you, Hub, for joining us.
Thank you, Tyler, for hosting me.
And we will definitely see you guys on the next episode of Make Live, and that'll be in July. Thanks so much.
Now remember what I told you.
Yeah, don't make eye contact. He takes it as a personal challenge.
Hello? Pat?
Yes.
Can I get a,
He'll take a Raspberry Pi 3.
No pie for you.
Told you. Hey, but I did hear this new deli. I can go pick up the sandwiches.
Don't be held hostage by the board order. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.